Hey everybody, this is Christian Horner. I'm a teacher in Westfield, Indiana, and I teach AP Physics at Westfield High School. And today we're going to talk about position and velocity. You're going to see me look over to the side every once in a while just because I have another screen so I can see if anybody's texting any questions or anything like that. But I just want to welcome you. I'm so glad you're here. We are going to just talk about position and velocity. We're going to find some really interesting things, I think, that maybe you haven't thought about at all. This session's about 55 minutes. So go ahead and ask any questions that you want to anytime that you need to. And tell me if we're going too fast, too slow, and I'll have some things that are interactive for us to do too. So hopefully that will be a good thing. All right, so we're going to look at position and velocity. We're going to think about where we are, and we want to think about how fast we are going. And we'll look at the difference between a lot of different things. So let's go ahead and anytime that you are on or you think about, hey, you know what, that was a good session, there's some things that I'd love to learn about, you can go on to Twitter or Instagram and go ahead and type in @ThinkFiveable and say, hey, I'd love to do an AP Physics 1 session on the difference between, I don't know, momentum in one dimension and momentum in two dimensions. Or I want to know, is there anything that I need to know for the test that talks about maybe waves or anything like that? So always go on. You can do @ThinkFiveable, and we will respond and let you kind of know what's coming up. You can follow us at @ThinkFiveable also, and we'd be glad to have you there. And that is kind of the fun part of this. There's some other streams this week. So I'm doing the position versus time graphs tonight. I'm sorry, I'm doing position versus time graphs tomorrow night. Tonight is position and velocity. So there's that going on. On the 18th, which is 16, 17, 8, that's Tuesday. Peter is going to go through velocity and time graphs in a lot more detail. And then on the 19th, Casey, who is an awesome student, is going to go through some problem solving practice and questions and answers. So if you ever have any questions or answers during any of these sessions, you do have the chat button just down in the corner. And all you got to do is just hop on that chat button and let us know what's going on if you have any questions or comments or anything, and we will be glad to go through any problems or questions that you have while we do this one too. So things that we're going to look at tonight, we're going to look at position and distance. And we're really going to make sure that you know the real difference between those two, because there's a lot of equations that you look at where they'll say D and you're not really sure, is that distance, is that displacement, kind of what is that? We'll talk about distance versus displacement. We'll also look at what is a rate. And then we're going to talk about speed versus velocity. We'll look at instantaneous speed. We will look at instantaneous velocity. And then we'll talk a little bit about average speed and average velocity. Hey, I'm just going to do a mic check really quick before I get any further along. If you can hear me, go ahead and just type yes. If you can't hear me, if you see my mouth moving, but you can't hear me, okay, cool, awesome. Hey, that's great. You guys are super interactive, and that's what I love when you guys type stuff. Beautiful. Thank you very much. All right, so this is position and distance. So we're trying to figure out what in the world is position. So there's positive position, there's negative position. Is zero really a position if you're zero? And then we're going to look at distance a little bit. So for example, let's say that I'm walking along and I am standing right here, okay? And if I am standing right here, somebody tell me, what is my position? What is my position? So if I'm standing right there, very good, Natalie. So Natalie says 1. And the interesting thing here about position is position needs to have some sort of unit with it. So give me a unit in physics that we might say that that person is standing at. Very good. So 1 meter. Meters is the standard unit that we will do. That doesn't mean that you won't see kilometers, that you might even see miles. because they want to make sure that you can do this in all kinds of different things. Good. So position is where you're at, is what Natalie is saying here. We could do inches, meters, miles, millimeters, centimeters, kilometers, angstroms, and do all those things. So that's awesome. Um, okay, so that person is at 1 meter, or we just say one at the position one. So let's go ahead and call this 1 meter. Um, does this person have a distance? That's my next question. So let me know, what do you think? Does this person have a distance? Because we see in a lot of problems, it'll say, we've plotted the distance versus time. And so you'll see maybe a graph, and it'll look like this, and it'll have distance in meters, and down here it'll have time in seconds. So you're right. I see a lot of you are saying no if they haven't, if they have not moved yet. If they move, then yes. If they haven't moved, no. And that's kind of my feeling too. So whenever we see a distance in meters, that means that this person had to have started somewhere. So if they start at the 0 position and they move to the 1 meter position, then we could say that, well, here's 0. We could say they are at 1 meter. And then we could also put down here, maybe this is 1 second. And so we'll just say that they were right here. So they started here at 0 seconds, and then they moved to here. And so that's 1 meter. And they did that in 1 second. Okay, cool. But that's not always true. We don't always start at 0. So let's say that that person really isn't right here. Instead, they were at A. The person started at A. Alrighty. So now is my position at 1 meter also equal to the distance I traveled? And let's say that I started at 0 seconds here, and then I moved along and I moved over, and this is at 1 second. So the question I'm asking again is this position, so is my position right here equal to the distance? So is the position equal to the distance if I started at letter A and I moved over to 1 meter? So is my position equal to my distance when I'm at this spot? And I'll give you a second to reply here. Just checking out to see if anybody's going to type anything. Uh-huh. Okay, good. So Ellie says the position is 1 meter, and that is 100% correct. The distance is 3 meters. So how in the world did we get 3 meters? Well, if you start here and you move in this direction and we go to here, then I see Natalie has said, she said the same thing, and it is 1 plus 2. So here we've got 1, 2 meters that we've moved. And even though the numbers here are negative, we're going from this position and we're moving over to 0. So that would be 2 positive meters plus 1 more meter. And then that would be a distance of 3 meters. Very good. So that's 3 meters. But that is not equal to our position that we ended up with of 1 meter. So we want to be really careful that whenever you do a graph, that you always make sure that, I would always use change in position if you want to talk about distance, but I would always call this position or X and put that in meters. So I know my students, they have a lot of trouble with this at first. And so we always talk about, let's just always plot position. Don't ever say that you're plotting distance unless that's what the College Board on the test is trying to tell you, which is really weird. So we've got position here. And let's say that this position is 0, and then we've got 1, and we've got 2 meters. Here we've got -1, and we've got -2. So I started at time equals 0 right here, and then I went all the way over to 1 second. So we're going to go over to here. All right. Yeah, this is AP Physics 1, Carlos. So AP Physics 1, they don't, Fiveable doesn't offer AP Physics 2 yet, and doesn't have AP Physics C, but I'm sure that those are going to be in the works pretty soon. Cool. All righty, so let's go back to this. And we moved from this position up to this position. So now it's a little bit easier to see that we've gone from -2 to 1. And that would be our change in position now. So our change in position would be equal to +3 meters. Yeah. So, oh yeah, so that's it. And that's pretty good to do. All right, cool. Any questions about the difference between position and distance? Everybody good? All right, I don't see any questions, so we're going to move on. So that's the difference between, oh yeah, one more thing. Can I have a position of 0? Can we have a position of 0? Can we have a position of 0? Yeah, and you're right. We can have a position of 0. Can we also have a distance of 0? Can I have a distance of 0? So I've got one person say no. I have one person say yes. If I stand still, so for example, let's say that this was at 0 seconds, this was at 1 second, and then I'm going to plot at 2 seconds. Let's say that I stand right there. Now, can I have a distance of 0? So did I go anywhere from 1 second over to 2 seconds? And if you think about it, I didn't. So I didn't go anywhere. So my distance or my change in position, I started at, so remember this would be my final position, which is 1, minus my original position, which is 1. So my change in position, which is the same thing as distance, is actually 0 meters. So you can have a 0 distance and you can have a 0 position. So if I start at 0 and I end at 0, then that's it. Yeah. So somebody just asked, is change in position the same as displacement? And that's really the technical term. So let's go ahead and let's go on to vertical position just really quick, talk about it, and then we will go on and talk about change in position and displacement. And we can really see what the College Board is going to say and what that is versus an actual distance versus a displacement. Because remember, those are two different terms. So position can also be vertically oriented. In fact, you can do it any direction that you want to. So you can have position up and down, you can have it left and right, you can have it at an angle. So what I've done is I took a cliff, and you can see the cliff that I have on here. And if I have this cliff, I'm going to say up is positive. Now, does it always have to be positive? Does up in the physics world always have to be positive? And you're correct. It does not have to be positive, okay? I could make up also negative. And so when we're talking about direction, if you say up and you want it to be negative because you want down to be positive because you're moving in the downward direction, that's absolutely fine. So you can, as Natalie said, assign anything anywhere. You could also use north, south, east, west. You can use in and out. You can use left, right. So anytime you have a direction and you want to indicate that direction, you can do whatever you would like. If the question, though, says up is negative and down is positive, you'll have to stick to kind of what you see. So let's take a look here at one scale. Okay, so I've started this scale, and I've got a person standing on the cliff, and they are going to base jump. Alrighty, so they've got a parachute on their back there, and they're going to jump off, and then they're going to pull the parachute, and they're going to fall and safely land at position -4. Alrighty, so when you base jump, do you have to start the cliff at 0? You really don't. And you can actually start this anything that you want to. So you could start the cliff at 0, or if you wanted to, you could also start the cliff at 0, but instead of having up be positive, here we've got that up is negative. So up is negative this time, down is positive. And all I did was just flip that axis over. So you could see this as +1, +2, +3, and +4. All right, so we've done that. The other thing that I could do is I could make 0 where the ground is. So there's some advantages to doing this. When we talk about energy, we know that potential energy is the mass of some object times gravity times the height of the object. And so if I put this object and I have 4 at the top instead of 0, then it actually has some energy. Okay, it has positive energy. If I go back and let's say that I make it 0, and I could even make it like this if I wanted to, now this person would say there's no energy in that person when they jump, which is kind of weird. So sometimes we like to make the top of the cliff a positive number. So that's the height of the cliff. They'll say maybe it's a 4-meter high cliff, and then the person jumps, and when they jump down. So this person's position is 4. And what is the distance that they fall? So my question is, what is the distance that they fall? So if I start at the 4 and I go down to the 0 and the base jump, what is that distance? Yeah, so that distance is 4, okay? Is it positive 4 or negative 4 in this case? Ah, okay. So I see a lot of positives. I'm starting at 4 and I'm actually moving all the way down to 0. Okay. So that distance is going to be positive. But let's move on to the next thing because now we're going to look at displacement. So distance is the absolute value of your change in position. Okay. That's one way to think about it. Displacement would be the change in position. So we're going to look at it this way, and then we're going to have to change this. If I start at F, okay, and F, you'll see that the value for F is 3, and I move over to E, this would be my original position. So this is X original, and this is my final position. So this is XF. And I'm going to move from F and I'm going to go right on over to letter E. So let's figure out what is our displacement. So our delta X, and notice there's no absolute value there. If I start at F, I'm going to, that's my original position. I know this is change in position is equal to my final minus my original position. So my final position here is 3, and I'm going to subtract and say that my, my final position is 0, and my original position was positive 3. So from this, you'll see that I traveled a displacement of negative 3. And if we wanted to put a unit on it, we sure could. So we could say that that's negative 3 meters. So we're just going to say that this is our position and it is in meters. If we talk about the distance we go, the position, the displacement is something that we call a vector. And a vector is something that has both magnitude, so it has a number, and it has a direction. So it's either positive or negative, or it's left or right, or up or down. So just as long as you put a direction on it, it works. Over here, distance, this is what we call a scalar. And a scalar is something that does not have direction. So there is no direction at all on this one. If there's no direction on this one, and we try to do our math, remember we're going to use the absolute value now of that change in position. So this is going to be the absolute value of 0 minus positive 3. And if I do that math, I'm going to end up with negative 3 inside of the absolute value. So that actually makes it 3 meters. Okay, so that is one of the differences. But here's the second difference. Let's say that I start at XO, and let's say that I move from here, and then I travel all the way over to G, and I stop at G, turn around, and then I go all the way back over to E. So I've traveled from F to G, and then I traveled back to E. So now here's the other difference between distance and displacement. You can't just say it is the change in position. It's actually the sum of all of the change in positions and the absolute value of that. So if you look at it this way, you're going to see it in a really different light altogether. So we're going to look at the sum of all the different position changes. Over here, this is going to remain the same. It's still the change in position. So we said earlier that if I go from F to E, that I have a value of -3. So let's go back and say, well, I'm going to start at F, I'm going to go to G, and I'm going to go back to E. To somebody trying to solve for the displacement, you do not worry about the path. So the path doesn't matter. Does not matter at all. So path doesn't matter. The only thing we want to do here is we want to just look at the original and final positions. So we would do this in exactly the same way. We would still say the final position, which is at E, and that's because this is where we went. We don't worry about the fact that we stopped at G. We're going to start at F. We're going to move over to E. We do go to G, and then we come back. But it's like you took a picture of the person standing here, and then when they got done, when they totally were done with their trip, you took another picture of them here. You can't see the path that they went through. So that is for displacement. And that displacement is still -3. But if we do distance, you get to see and count this entire path. So I've got two different legs of this trip. So I'm going to do the absolute value of the first leg, okay? And then I'm going to add to that the absolute value of the second leg. So I'm just going to sum all those together. I guess I could put that there instead of on the other place. All right, so this is going to be our total change, and this is going to be our distance. So in the first part, I'm going to go from 3 to 8. So my final position for the first leg is 8. My original position is 3. And I have an absolute value for it, plus, and then I'm going to go from 8 to 0. So I'm going to take 0 as my final position, minus 8. But I have absolute value for it too. So 8 minus 3 is going to give me 5. And then 0 minus 8 is going to be -8. But remember, it's absolute value, so I'm going to add it. And if I add the two together, I get 13 altogether. So that's 13 meters. So notice we have a big difference between -3 meters for our displacement and 13 meters for our distance. So somebody earlier said, when you look at this, they wanted to know, well, I thought delta x is displacement, and you're absolutely right. It is displacement. When we do, anytime we do distance, you usually want to say distance. You want to write out the word distance. And then that indicates that you have to add all of these segments together. So this was segment 1, and that was segment 2. So just be really careful that if you're asked a question about distance versus displacement, that you choose the right way to do it. And I think that's the big thing for it. All righty. Now, let's practice a little bit and see what you guys get. So I'm going to take a little trip here. I'm going to start at this position, and this is letter B. And at letter B, I'm at -7 meters. And then I'm going to travel to letter C. So this is my first trip. I'm going to go over here. And I get bored waiting. I'm waiting on somebody. So I go ahead and take another trip, and I go over to D. And then when I'm done, I think, well, maybe I need to go back. That person can't find me. So I go back to C again. And then I think, well, maybe I totally missed them altogether. So I'm going to go all the way over to A. And then I think, oh no, you know what? I'm on the wrong side of town. So then I travel all the way over, and I move over to G, okay? So this was all just lateral movement, but I had to draw it this way so that you could kind of see where I'm going. What I'd like for you to do is I want you to do two things. I want you to find out what is the distance, okay? And then I want you to find the displacement. Take your time and do that. And when you give me an answer, I'd like you to put D is equal to for distance, and then tell me how far I went distance-wise. And then delta x, remember, is displacement. And you can tell me how far I went in terms of displacement. Okay, so here we go. On your mark, get set, go. I'll give you about a minute to go through and do that. And go ahead and just put D for distance and put, you can just put change in X, or dx would be for delta X. And I'm going to open my calculator so I can do the same thing. We'll give you a few minutes here. So I started at -7, I went to -1, then I went from -1 all the way over to -9, and made a little stop there at -4, and then I went from -9 all the way over to G. Yeah, very good. So I've got Natalie, who has told me that my distance is 30 meters. And my change in position is just a little bit more than half that. So it's 16 meters, and those are correct. So if you'll notice, when you start here, go all the way to D, and then come back and make those stops, that distance, I have to add everything together. So a lot of times I just tell my students, just make these all positive, and then it works. So somebody said, why isn't delta X 15? So let's check. So this is 9. And so we traveled a change in position here of 9. And then we went another one all the way over to here. Oh, you know what? We did start here. So we went 7. So 9, 8, 7. So yeah, this one is 7. So I went 7, okay, to here, and then this is 8. So 7 and 8, aha. So thank you very much. So it looks like Abofu has found that it is, instead of 16, it is 15 meters. Yeah, so sometimes it's hard to see when there's not a number there, but there's our number that we started at. So that is right. Cool. Very good. So thank you for helping Natalie out. That is 15 meters. So it is actually half of the total distance if you count the total distance. Excellent. All right, so let's go ahead and take a look at this. This track is 100 meters from start to stop. All righty, and I've got somebody who runs a race, and they run 5 laps. So you'll commonly see something like this on a multiple choice for the AP test. And answer A for this is going to be 0 meters. Answer B would be 5 meters. Answer C would be 100 meters. And then they would put answer D, and that would be 500 meters. Okay. And there's 2 questions that they could ask here. The first question is, what is the distance? So what is the distance that the person ran if they ran around the track 5 times? So what would be your answer? So go ahead and pick an answer, A, B, C, or D. What is the distance that you run? So you're starting here, going around 5 times, and then you are ending up here. And so Ellie has said D, which is 500 meters, and everybody else is saying D also. Good. So that one's 500 meters. The next question is, what is the displacement? So what is our delta X equal to? Yeah, Ellie has A. Anybody else? Do you agree with her? Do you think it's different? Yeah, so there's another one. We do have A. Perfect. So that one is A, because you're starting and stopping at the same point. Notice that they've also included 5 meters because they said 5 laps, and 100 meters because that is the distance around the track. On these tests, you're always going to have answers, they're matched numbers, or are maybe the 2 numbers added together, multiplied together, or divided by each other. So always expect that if you can do it mathematically, they will probably put that answer there. The one that a lot of kids would not pick because it looks like a distractor is that 0 meters. But when we talk about displacement, that is actually correct. All right, cool. So that's our track. Let's talk about rates a little bit, and that'll take us into speed and velocity. So what is a rate? A rate is anything that you are measuring how much in a certain period of time. So it is so much in a period of time. Bye, Natalie. Thanks for hanging out for a little while. All right, cool. So texting rate. If I sit down, I could probably say that I could text maybe in a minute. I could probably text about, I don't know, 30, 40 words or so. So 30 words in a minute would be a rate. Okay, so I'm just looking at the change in something over the change in time. A running rate. So some people will run a 5-minute, M-I-N-U-T-E, a 5-minute mile. A 5-minute mile. That could be a rate, but we'd have to flip it. So that means that they run 1 mile every 5 minutes. I tell you, I can't spell tonight. All right. So 1 mile every 5 minutes. And then I could find a speed from that. Flow rate. If you think about a garden hose and you have water coming out of a garden hose, you could do a flow rate. So we could talk about the number of gallons of water that come out of that every hour. You could do that every minute, every second if you wanted to. Eating rate. I ate 5 cheeseburgers and I did that in 20 minutes. So that's another rate. So rates are just anytime you have something that you can measure and you divide it by the amount of time that it takes to do that thing. Let's go ahead and take a look a little bit at speed and velocity. So remember when we had distance and we had displacement, one was a vector and one was a scalar. What is speed? Is speed a scalar or a vector? Does speed have direction? So is speed a scalar or a vector? Yeah. So this one is a scalar. And so for this, we only have just a number and a unit. So for example, I might say that I have a little buggy cart and it's going 5 meters per second. So I got a kid riding down the road and they've got a Segway or they've got a 2-wheel scooter that's electric and they're just going down the road and they're going about 5 meters per second. Okay. Velocity is also rate. However, we have to make sure that we understand it is a vector. So whenever you have a vector, remember we're going to have a direction. So this one could also be 5 meters per second, but we need to give it a direction. If you put a positive in front of it, does that give it a direction? What do you think? Yes or no? So I see 1 yes. I see 2 yeses, 3 yeses. Very good. So this does give a direction. If you put a positive in front of it, it gives a direction. If you leave the positive off, it does not give a direction. However, it is understood that that is in the positive direction. So for it to truly be a velocity, you really need to include this positive, or I could put 5 meters per second to the right. You could also say that positive could be to the left if you want to. So if I draw a number line and I want everything to the left to be positive, I just draw it and put the positive on the left side. So you can do that without any trouble. If you have a car that's moving, I would always put your velocity as positive. And the reason that we do that is if I say my velocity is positive in this direction, but I have an acceleration that is going in this direction, is my car speeding up or slowing down? What do you think? My velocity would be positive, but my acceleration would be negative. Is my car speeding up or is it slowing down? Yeah, and Jasmine is correct, and so is Ellie. It's slowing down. So when the two signs are opposites, that way we know that it's slowing down. And so I always tell my students, whatever direction you're moving, make that positive. It could be up at an angle, and so this could be my positive velocity. It could be straight up if I want to. But I always try to get it so that the direction of motion is positive. And then that way acceleration, if it goes with it, is positive. If it doesn't, it's negative. And then they know something is speeding up or slowing down. All right, cool. So that is rates and a little bit about speed and velocity. Okay, cool. So let's go back to our track again. And this track is 100 meters. And that means that I can go all the way around. So its circumference is 100 meters. I want to know the speed. Let's say that it takes 25 seconds, and that's equal to my time. I know that my original position, so XO, is equal to 0 meters, and my final position is equal to 100 meters. What is my speed? Okay, what is my speed if I go around the track one time and I am right here? So I'm halfway around. What would my speed be? And it takes 25 seconds to go all the way around. Okay, so and if I'm running at a constant speed, what would be my speed at this point? To do that, we're going to use our speed equation. So speed is equal to, and remember, we're going to use distance divided by time. So our distance here is, instead of the final position being 100, it's going to only be 50 meters. So I'm going to go halfway around here. So that means that I've gone a distance of 50 meters, and my time is going to be half of 25. So that would be 12.5 seconds. One thing you want to be really careful of is that on the AP test, it's tempting to do things in fractions because you know that that's a little bit more precise. But in this one, we want to go ahead and divide it out. So 50 divided by 12.5 is going to give me that 4 meters per second. So that would be my speed. My question is now, what is my velocity? What is my velocity on this track? If I go starting right here, and then I travel all the way around to here, can you find this? Can you find the velocity based on what I've given you, or do you need something different? And I'll let you think for a second. Let me know, do you want more information, or can you find the velocity for this person? What is the velocity, the average velocity there? So I'll give you two options. You can either say, yes, I can find it, or no, you need to give me more information if I want to find the velocity. So I've got one person has voted no, they need more information. Anybody else? So they are correct. We do need more information because remember, we need to know what is that starting position. That starting position is 0 meters. The final position over here, we're going to say that that is actually 10 meters if we're talking about velocity, because remember, we don't want distance, we want change in position. They are here. I know they run all the way around, but if I open my eyes and I see them here and close them, and then when they say I'm done, and then they are here, we're going to say that that distance from, and it's a little hard to see, so we're going to go there to there. So this distance, so this line right here is only 10 meters. So this is a trick question that they do for this. So your velocity, remember, is going to be change in position over change in time. All right, we still have that 12.5 seconds is how long it took them. But we started at this point and we don't know what path they took. So we're going to do, sometimes they call this as the crow flies. So from here to here, or if you took a helicopter, or if you just jumped or teleported, kind of totally up to you. So now I've got 10 divided by 12.5. So 10 divided by 12.5 is going to give me 0.8. So here the velocity is 0.8 meters per second. So big difference between the two. So just make sure you're really careful that you have all the information you need to answer a question like that. All right, let's go ahead and take a look at some practice things, okay? So let's say that I'm traveling and I start at, let's start at letter B again. So this is -7 meters. And let's say that I start here at B, I travel all the way over to E, and then when I'm at E, I then travel all the way back over to B again, and then I turn around and I go all the way over to G. Alrighty, so now I've made all those movements, and let's say that this took me 5 seconds here, this took me 5 seconds to get back, and then it took me 12 seconds to go this distance. What I'd like for you to do is I'm going to have you find two things. I want you to find speed. So we're going to go speed. We'll just say speed is equal to. So when you're done, go ahead and type speed is equal to. And then I want you to tell me what is my average velocity. So what is my average velocity? And then we're going to talk about average and instantaneous velocity here in just a second. What is my average velocity for my trip? And what is my average speed for my trip? So this would also be an average. Alrighty, so on your mark, get set, go, and I'll give you a couple minutes to do this. I want you to find, we've got our times, and don't forget you're going to need to find your distances too, or your change in positions. Alrighty, go ahead. Okay, cool. So Ellie got an average speed. So I'm going to write this down. Ellie got an average speed of 1.32 meters per second. So we'll write that one down. Anybody else have an answer for speed or average velocity? Over on the side, I'm going to solve this for average speed. So I'm going to put SAVG. And I know that is the total path. So it's going to be -7 to 0, which is 7. And then back again, that is now another 7. So that's 14. And then I'm going to take 14 and I'm going to add to it. Okay, cool. So good, got another one. So this is 7 plus 7 is 14. And then I'm going to add another. And if I go from 7 to 8, you'll see that that's 15. So 14 plus 15, that gives me 29. So that'd be 29 meters. And then what's my total time? So my total time here is 5 plus 5 is 10, plus 12 would be 22 seconds. And so if you take that 29 divided by 22, you would be correct. It is 1.32, and then that's meters per second. So that's my average speed. What is my average velocity then? And Ellie got 0.7. So let's just double check and make sure that Ellie is right, 0.7 meters per second. So we say that if we start at B and we see that person and all of a sudden, boom, that person has teleported to G, but it's taken them 22 seconds to do it. They went 15 meters, and we know that they did that in 22 seconds. So if I take 15 divided by 22, I do end up with about 0.7 meters per second, which is correct. So excellent job, Ellie. That was very good. Cool. So now we know the difference between speed and velocity. Our velocity here, it would be positive. So we're going to put a positive in front of it, and then we should be good. All right, I see a weight. Ooh, wouldn't it be negative? So what would be negative? The speed or the velocity? The speed or the velocity? Okay, so let's check. Remember, our velocity would be our final position minus our original position divided by our change in time. Our final position is 8. So we're going to put that in, and then we're going to subtract from that our original position, which is -7. If I do that and divide it by 22, 8 minus -7 is actually 8 plus 7. And so 8 plus 7 is our positive 15 divided by 22. So if we start at B and go to G, then we would have a positive 0.7 meters per second. If I went the opposite way, though, if I started at G and then went the other way, then I would have an average velocity that would be different. Yeah. Hey, you know what? It's great to make mistakes because you learn a ton from your mistakes. So that was perfect. Very nice. Okay, cool. All right, let's move on. Motion maps. Motion maps are another way to show the difference between displacement and distance, but they're also a good way to kind of show how things are going in the positive or negative direction so that we can get a either a constant speed or a constant velocity. So constant speed in the positive direction. Let's say that I'm going 1 meter every second. If I'm going 1 meter every second, this is 0 seconds. And then this would be 1 meter. So this is 1 second. Here's 2 meters, and this is 2 seconds. And then I could just keep going all the way across here. So now I have a constant speed in the positive direction. My arrows indicate my speed. And because I traveled 1 meter in 1 second, this would be a 1 meter per second length arrow. This one is also 1 meter per second. So same thing all the way across. If I do this in the negative direction, notice that instead of going to the right, I have to go to the left. And it's because I have my positives over on the right side. So same thing again. I'm going to start at 0 seconds. This is 1 second, 2 seconds. I get over here. This would be 3 seconds, and I just keep moving. But my speed here is still going to be 1 meter per second. So if you need to tell direction and all you give is speed, you're going to have to add that word to it at the end. If we switch this and we take a look at constant positive velocity and constant negative velocity, then I can add my, my direction right on the speed vector itself. So this is positive 1 meter per second. This one is positive 1 meter per second. And then I just keep going. So this would be another positive 1 meter per second. If I start here and I go this direction, now I have negative 1 meter per second because now I'm talking about velocity. So you just have to be really careful that you're always indicating either using a positive or a negative for velocity, or you're saying left or right. I think that's the most important thing. All right, cool. So let's go over to something that's really important. And this is the difference between instantaneous velocity and average velocity. So let's say that we go to Germany and we're on the Autobahn. That is the highway where you can go any speed that you want to for the most part. And we're going to go from city A, and then we're going to go to city B, and then we're going to go to city C. Okay. And let's say that right at this point, we're going 350 meters per second. Now, you probably aren't going to go that fast, but nonetheless, 350 meters per second. And at this point right here, I'm only going 200 meters per second. So these are instant velocities. This is, I look down at my speedometer, and at that particular time, I'm going 200. Here I'm going 350. Let's say at the very beginning here, I'm going 450 meters per second. So those are instant velocities. If I take those and I just say, well, I'm going to go from here to here, and so along A to B, I'm going to go 25 meters. And let's say that the time takes me, I don't know, let's just do 12.5 seconds. Now my average velocity, I've got all these speeds in between that I never really pay any attention to. I'm just going to divide the two because now I want average velocity. So average velocity usually has a bar over the top. And instantaneous velocity would not have that bar over the top. It might have a vector line like that, but this one, notice, doesn't have that little hook on it. And so my average velocity here is equal to 25 divided by 12.5. So if I do that, I'm going to end up with my 2. So 25 divided by 12.5 is 2. And so my average velocity is positive 2 meters per second. This is where people get in trouble. So here's a question. It says you drive 60 seconds at 22 meters per second, and then 20 seconds. Yeah, I can go back. So let's go back. All right, what question do you have? So I'll give you a second here. Yeah. Okay, for the instantaneous, So these are my instantaneous velocities here. Yeah, we are talking about at a specific point. So somewhere in between A and B, when I was traveling, I looked down at my speedometer in my car. And my speedometer in my car, it's a physics car. I went too far there. It's a physics car. And so because it's a physics car, I can look and I actually have a speedometer there. And that speedometer tells me that at this point, it says 450 meters per second. And then over here, it says 350. When I did this, I wasn't really looking at it to any specific point. I was just looking, well, I probably was traveling to here. I was probably traveling to here. I was probably traveling to here. And that's really what an average does, is it tells you, well, it could have been that along any point along the line. That doesn't mean that that's what you actually did. And that takes us to our very last one. Does that make sense? Awesome. Good. Cool. All right. So with average velocity, you have to be really careful. I drive 60 seconds at 22 meters per second and then 20 seconds at 76. What's our average velocity? So a lot of people right off the bat, they do this. They say, well, I've got two values. I've got 22 meters per second, and I'm just going to add that to 76 meters per second. And then I'm going to divide that by 2, because isn't that the average of the velocities? So we'll do 22 plus 76. That gives me 98 divided by 2, and that gives me 49. So if you do it that way, you would come up with a number, and that would be 49 meters per second. And because it's average velocity, we're going to assume that everything's positive, so we're going to put that there. But that's not really the answer. Remember, average velocity, so V average, or you can write V with a bar over it, is equal to my change in position divided by my change in time. So let's figure out how much time did we actually drive here. So 60 plus 20 is going to be 80 seconds. So there's our total time. But we don't know what the total distance is here yet, or the displacement. We have to find that. So to find that, what we're going to need to do is we have to remember that velocity is equal to change position over change in time. And we need to find out what is the change in position here. So change in position is equal to the velocity times the time that we travel. So I'm going to take 60 times 22. And if I do that in the calculator times 22, I end up with 1,320. And so I know I traveled 1,320 meters here. And then 20 times 76 gives me 1,520 meters. So my total change in position, or the total that I went since I went in the same direction, is going to be the sum of the two. So that's going to be 2840 meters. So that's 2840 meters. So let's see if that's 49 meters per second. So 2840 divided by 80 is only 35.5 meters per second. So let's go back and do that one more time. If I drive 60 seconds at 22 meters per second, let's think about this as position. So my original position here is 0. And in 60 seconds, I actually go 1,000. So this is 1,320 meters. And that took me 60 seconds. Then in 20 seconds, which is a lot shorter time, I go a lot further. And so because this is a number line, I'm going to make this longer, okay? And this is 1,520 meters. And I did that in 20 seconds. So the question is, what is my final position so I know how far I went and how much time did it take? So that's one way to look at it. If we look at it in terms of time, you would say I went a long time and then I went a short time, but I went a really short distance compared to the other one. So this one's 1520. So this would be for time. So this is my original time and this is my final time. So here I went for 60 seconds and here I only went for 20 seconds. But because I was going so fast, I covered a lot of ground. So be very careful that when you find average velocity, if they give you two speeds, you don't want to add them together and divide by the number of speeds. That's not really average velocity, unless all your times are the same. And then you could probably get away with that. But here, you're not going to. So you've got to find out, how far did I go at that speed? How far did I go at this speed? And I have to multiply the time times the distance. All righty. That is really all I have for you folks tonight. I really appreciate you showing up and going through and answering some questions. That was awesome. Remember, go ahead and spread the word that we're out here. You can go out and tweet or use Instagram and say, hey, I just learned about position and velocity from Mr. Horner or from Christian at Think5able. And that's it. Anybody have any other questions or anything? All right, cool. Thank you, guys. Hey, I appreciate you sticking around. We will see you later. Make sure you come back. We're going to do some more tomorrow and then lots more this week. Talk to you later. Thanks, guys. Bye-bye.